This lesson is what I'm calling an F&N Roundup. So you will need your periodic table of ions, and your polyatomic ion chart. So we're going to do both ionic and covalent compounds. So we're going to make a flow chart here for how we're going to be able to name our compounds properly. All right, so the big question we want to ask ourselves is this the first element in the compound to the left of the staircase, or does the compound begin with NH4 or ammonium? So that's our big question. Is the first element to the left of the staircase, where our metals are except for hydrogen, or does the compound begin with, if it's a formula, does it begin with NH4? If it's a name, does it begin with ammonium? Okay, so that's the most important thing, looking at that first element. All right, so we have two possibilities here. So if we answer yes, we do have our first element to the left of the staircase, or ammonium. Then we're going to use the stock system that we learned first. And when we're using the stock system, remember, this is where we're crossing charges. We are using Roman numerals if necessary. And we are reducing to lowest whole number ratio, anything outside of the parentheses. All right, now what about if our answer is no? Okay, now we have another question to ask ourselves then. Is the compound binary? And remember, binary just means there are two elements, kind of any number of atoms, but only two elements. So you have two choices here. And we'll do the no, it's not binary, it has three or more elements. Well, we're not going to do that. We're not going to do those naming systems. They're a little more complicated, and if you take organic chemistry at some point, you might get into that. So we're not. All right, so is the compound binary? If it is, then we're going to ask ourselves another question. Is the compound a hydrocarbon? So we already have that it is binary, but now, is it a hydrocarbon? Does it contain carbon and hydrogen? All right, two possibilities here. Yes or no. If it's not a hydrocarbon, and we only have two compounds, the first element to the right of the staircase, then we use the prefix system. And here the compound ends in IDE, and we have a prefix for the number of atoms of each element. Okay, now, what about if our binary compound is a hydrocarbon? Okay, then we're going to use our hydrocarbon F&N system. We only did a small subset of those compounds. We're going to use the hydrocarbon F&N system. Okay, so now our compound name ends in ANE, not IDE, we end in ANE, and we use a prefix for the number, going off the page here, prefix for the number of carbon atoms. So we have methane, ethane, propane. Okay, for both of these, this is really important. We do not reduce our subscripts to lowest whole number ratio. Oh, I'm running out of room. Ratio. So for our stock system, we do. For the prefix system, we do not reduce those subscripts. And that's because our compounds, the smallest unit is a molecule that can have any number of atoms in it, where for our ionic compounds, the smallest unit is a formula unit. And the definition of that is that it's the lowest whole number ratio of the ions. All right, so let's do some examples here. Okay, so we're going to look at these two, and this is a little crazy here. We have AlCl3, and then we're going to look at BCl3. And we want to write the names of those compounds. So we have our periodic table, and we look at where aluminum is. Aluminum is to the left of the staircase. So following our flow chart, that means we do use the stock system. The stock system, aluminum is a type 1 metal element, so we do not need a Roman numeral, because our rule is if our first element is in group 1, group 2, or the slide, and the slide contains aluminum, zinc, and silver, we don't need a Roman numeral. So we write the cation name, aluminum, and then our anion name, well, that is the chloride ion. So our name is aluminum chloride. Now, let's do BCl3. So we look at where boron is on the periodic table. Boron is to the right of the staircase. So we need to use the prefix system. So the prefix system, we have one atom of boron. So our first element doesn't get the mono, so it's just boron, the full name of the first element. And then we use a prefix for the number of our second element. So this is trichloride. All right, so this might seem a little crazy. Aluminum chloride and boron trichloride. They look the same, but here we do not put the tri. Here we must put the tri. So this first element is extremely important so that we know the proper system to use. And there are different systems, but for us in our class, we're always going to use the stock system for elements that begin to the left of the staircase, and we're always going to use the prefix system if our first element is to the right. Okay, so let's do some more of these. All right, so CuSO4. So we look at where copper is on the periodic table. Copper is a metal, is to the left of the staircase. We're using the prefix system. So we write the name of our cation. So this is copper. Now, copper is not in group 1 or group 2, nor is a part of the slide of aluminum, zinc, and silver. So copper does need a Roman numeral. So copper, we'll leave our open parentheses. And then SO4, that's the polyatomic ion sulfate. All right, so we need to figure out what goes in here. So we're going to box our formula. So SO4, we have one SO4 polyatomic ion. And we have one copper ion with a positive charge. And that's it. We only have two ions in our formula. The whole thing has to equal 0. The sulfate is -2, so that means we need a +2 to balance it. So that means this one copper must be a +2. So we put Roman numeral 2 in our name. So our answer is copper Roman numeral 2 sulfate. All right, our next example, Pi5. So we look at where phosphorus is on the periodic table, and we see that phosphorus is to the right of the staircase. So now we just use the prefix system. We don't care about charges, doesn't matter. So prefix system, we have one phosphorus, so we don't need the mono. So phos for us, the first element gets its full name. And then it ends in IDE. We need to indicate there's 5, so that's our prefix, penta, iodide. That's it. Phosphorus pentaiodide. All right, let's look at another example. NH4, 3, N. Okay, so NH4, this is a polyatomic ion. It is on your polyatomic ion chart. It's the first one. So this NH4 is the ammonium ion. So that is its name. Ammonium does not get a Roman numeral. Ammonium is always a +1. It's never any other charge, so there's no reason to indicate its charge, just ammonium. And then N, this is the nitrogen as an ion, which is nitride. Ammonium nitride. And that's it. Okay, let's look at another one. N2O. So now we look at where nitrogen is on the periodic table and is to the right of the staircase. And we then are going to use the prefix system. We have two nitrogens, so dinitrogen. And then our second element has one atom. Now we must use the mono. So it's dinitrogen monoxide, monoxide, monoxide. We just kind of smush that together. All right, and then CH4. All right, so carbon, it's to the right of the staircase. However, look at our elements. We have carbon and hydrogen. This is a hydrocarbon. So now we use a prefix for the number of carbons, and that is meth. One carbon is meth, and our ending is ane. Okay, so you probably recognize that as our Bunsen burner gas, methane. All right, so now let's do some names to formulas. All right, so we're going to start out with titanium, Roman numeral 4, chromate. Okay, so our first element, titanium, it is a metal. It is to the left of the staircase. This is the stock system. Okay, so we're going to write the formulas for our ions. So titanium is Ti. This Roman numeral 4 says that the titanium is a 4+ ion in the compound. And then chromate ends in ate or ite. Check your polyatomic ion chart. And chromate is Cr O4. That's an R. And that has a 2- charge. Now we cross our charges, the absolute value of our charges. And then we check 2 and 4. We only check outside parentheses. 2 and 4 does reduce. So 2 goes to 1, 4 goes to 2. So our ratio is 1 to 2. So we rewrite Ti, parentheses, Cr O4, parentheses 2. We must keep our parentheses because we have two polyatomic ions. Okay, our next example is diphosphorus. Oh, no, this is decoxide. I had my formula written down wrong on my notes. Diphosphorus decoxide. Okay, so phosphorus is to the right of the staircase. We're using the prefix system, which is obvious because we have prefixes in the name. So this is P2, di is 2, and oxide, that's O, deca is 10. We do not reduce those to lowest whole number ratios. We do not. One molecule of the compound has 2 phosphorus atoms and 10 oxygen atoms. So we have to be very careful about when we reduce, like here, and when we do not, like here. All right, let's check another one. Silver sulfide. Okay, so silver to the left of the staircase. It is a metal. We are using the stock system. So now we have to write our ion symbols. Silver is part of the slide. So let me remind you, the slide is aluminum, zinc, and silver. Aluminum is 3+, zinc is 2+, silver is 1+. All right, so silver, Ag+. Sulfide, it ends in IDE. This is the monatomic sulfur ion. It's not polyatomic. S, we look on the periodic table, and we see that we have a 2- charge. Cross 1 and 2, and rewrite, because 2 to 1 is the lowest whole number ratio. Ag2S is our formula. Okay, let's do a few more. Magnesium nitrate. All right, so magnesium, it's to the left of the staircase. It's a metal. We're doing charges. So magnesium, Mg, it's in group 2, 2+. Nitrate on your polyatomic ion chart, it's NO3 with a -1 charge. Cross to the outside of the parentheses, 1 to 2 is lowest whole number ratio. Rewrite it, Mg, parentheses, NO3, parentheses, 2. Okay, let's say oxygen difluoride. Okay, oxygen. It's to the right of the staircase, so we are using the prefix system. So there's no mono here. You don't need the mono. If there's no prefix, it just means you have one of that element. And then difluoride, so fluoride from fluorine. Di means we have 2 fluorine atoms. Our formula is OF2. Iron, Roman numeral 3, hydroxide. All right, so iron is Fe. It's to the left of the staircase. It's a metal, so we're using the stock system. 3, Roman numeral 3, means it has a 3+ charge. Hydroxide, OH, this is on your polyatomic ion chart. It has a -1 charge. Cross, cross, Fe, parentheses, OH, parentheses 3. We must have the parentheses there. Okay, and we'll do one more. Propane. Propane, it ends in A-N-E, and prop is a prefix for our hydrocarbons. So we have a hydrocarbon here. So we have C and H. Prop means 3 carbons. And then we can either draw it to figure out our hydrogens, or if you remember the formula, it's 2 times 3 plus 2. So 8. But if we draw it, C, 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 because carbon is bonded to carbon. Each carbon gets 4 bonds around it. And we're going to fill those in with hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. That is propane. That's what's in your gas grill tank. It is a fuel. All right. So when you are writing these, when you write the iron Roman numeral 3, this is all together. You leave a space, then write hydroxide. But when you write formulas, they're always all together with no spaces in the formula. And when you were answering these in Google Classroom, always start your name with a lowercase letter. Okay, that's it for today, kids.